Welcome to this video on inverse normal distributions and the normal calculator in StatCrunch. After watching this video, you will be able to use the normal calculator in StatCrunch to find the value or values of a random variable given the probability using both standard and between settings. This is called inverse normal probability. Introducing the normal calculator in StatCrunch. Go to statcrunch.com, log onto the site, click on Open StatCrunch, and then click on Stat, Calculators, Normal. Inverse normal probability example 1. Suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. What test score separates the bottom 10% from the top 90%? Round your test score to the nearest whole number. Let's try to visualize this example. Here we have the normal distribution. What this problem is asking us to do is to cut this normal distribution into two pieces so that 10% of the area under the curve is to the left of this line and 90% of the area is to the right of it. What they want us to find is the actual x value where this line lands. I've drawn the line here, but I just guessed where it would be, and I don't actually know the specific x value. For that, we need to go to StatCrunch. Here we have the normal calculator in StatCrunch. The last problem I was doing was in the between setting, so I need to click back on the standard. Now, the value that I'm given is not a z-score, but a probability. So I need to do a few things. First, I need to clear both of these values. Then, remember, I want 10% of the area to be to the left of my z-score. So I'm going to change this to a less than sign, and then I'm going to type in 0.10. When I hit compute, I find that about 10% of the area under the curve, or 10% of the population, has a test score that is below about 55. So the test score that separates the bottom 10% from the top 90% is about 55. The value here has been rounded to the nearest whole number, and notice 55, or about 55, is the line that separates the shaded region in the graph from the unshaded region. Let's re-examine this problem. Again, the question asked us what test score separates the bottom 10% from the top 90%. So our approach in the previous example was to feed the computer this information of less than 10%. And then, of course, it generated a value of about 55. Can you think of a different way to put in the same information and get the same answer? Well, what if instead of putting in less than 10%, we had asked for greater than 90%? Notice that the line, the demarcation between the shaded and unshaded regions is exactly the same. It's in the same place. The only difference is in the left graph, we're shading the region to the left of this line, and in the right graph, we're shading it to the right. Notice that in both graphs, we have the exact same value for the random variable, which is 54.621381, or about 55. So as you go through these problems, either approach is equally valid. You can decide if you want to ask StatCrunch to shade the left side or to shade the right side. Again, making sure that you put the appropriate percent. Example 2. Suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. What test score separates the bottom 80% from the top 20%? So let's interpret this visually on a graph. So we need to cut this normal distribution into two pieces so that 80% of the area under the curve lies to the left of our cut, and about 20% lies on the other side, to the right of the cut. So remember, the first thing we need to do in StatCrunch is to clear both of these fields. And then if we want the left area to be to be 80%, then we make sure the less than or equal to sign is selected, and we type in 0.80, and then we hit compute. So the x value, the test score that divides the lower 80% from the upper 20%, is about a test score of 80. Remember, if we wanted to, we could, instead of doing less than or equal to 80, we could also type in greater than or equal to 20% and hit compute, and notice that the same random variable value, about 80, comes up. So we say that the test score that separates the bottom 80% from the top 20% is about 80. Again, we could do what we did at first. We could type in less than or equal to 0.8, and we get this answer here, about 80. Or remember, the other option is we can shade the upper 20%, putting in greater than or equal to 0.2, and either way, we still get the same value for our random variable. Example 3. What test scores separate the middle 50% from the rest? Round test scores to the nearest whole number. So let's visually interpret this. We want to find two values, 1, 2, that separate the middle 50% of the data from the rest. So we have 1, 2 different values of the random variable that we're asking StatCrunch to find. If we look at the normal calculator, unfortunately right now, there's only one spot for one random variable. So just like we've done in previous problems, we need to come up here and click on between, and now our random variable is sandwiched between two numbers. So anytime you're doing an inverse normal probability, you always are going to need to clear out all of these values. So remember, the percent that we're interested in is 50% or 0.5. Let's hit compute and see what happens. So now the middle 50% of data has been shaded, and we have two values of the random variable, the left side cut and the right side cut, that separate this shaded area from the area on the left and the area on the right. When we round our test scores to the nearest whole number, we find that the test scores that make up the middle 50% of scores are values between 62 and 78. Again, rounding these two values to the nearest whole number. Having watched this video, you should now be able to use the normal calculator in StatCrunch to find the value or values of a random variable given the probability using both standard and between settings.